Hello, everyone, and welcome back. Today, we're going to take on a really important topic in artificial intelligence, and that is the world of computer vision. Now, we've spoken before in this forum on a number of AI techniques, and we spent some time on natural language understanding. NLU is actually one of the most advanced forms for AI in terms of its maturity, and we put that into practice in many different client and commercial engagements. Today, we're going to change the focus and dial it up a little bit, and we'll get into sort of the next one right on the heels of NLU that we're starting to see achieve maturity, and that's the world of computer vision. And to help us unpack that a little bit, I've asked someone to come back who's been here before. It's Dr. Armen Kherlopian. And for those of you that haven't met Armen before, he's with us. He runs a number of our AI and data science projects. He works closely with clients and large corporations and small across the globe. And he spends time with the research community and with the academy on keeping us on our toes and what's happening in new advanced fields. And so with that as a backdrop, I'm going to level set and I'm going to pull us back. First off, Armen, welcome.
Thanks, Sanjay. Great to be here.
And give us, in a few words, a simple answer to what exactly is computer vision?
Certainly. Computer vision involves understanding unstructured information from images. And it is largely inspired by biological vision, how we see, and embedding those algorithms, those sequences of learning steps into machines.
Okay. And you call it unstructured. What's this whole thing about structured and unstructured? And how does that relate to the world of images? Connect the two for me.
Certainly. So with natural language understanding, you'll have unstructured text. It's free-flowing. And to help analyze that data, one may want to structure it. For example, count the number of positive sentiment words or identify who's speaking in a narrative. This involves taking that unstructured story and structuring it. Similarly, in an image, you have an unstructured sequence of pixels, but you want to understand, is there a person in this scene? Is there multiple people? Are they interacting with a product? Is there a sentiment being conveyed? Things we can do very well, but computers have classically struggled to identify.
That's super interesting. I think I understand what you're saying. Look, I was talking to my mother the other day, and my mom actually is able to pull up her iPhone and take up one of the grandkids' photographs and then use that to find all of the other photographs of the same grandchild in her iPhone. And that's really, I think a little bit what you're talking about is something that all of us experience every single day, which is you can go into your Google phone or your iPhone and you can bring up all your vacation photographs or all your holiday photographs, all the photographs that you've got you've got your pet in. And I think what you're saying is that involves computer vision because it allows you to understand what's in the image and then structuring it so you're labeling all of those different images in different ways so you can go back and search for it. Is that what we're talking about here?
Absolutely, and that's a great use case, namely around visual search, finding friends and loved ones in an image. And one of the ways that this is possible is that as we look around in the world, we'll see objects, we'll see people, things like faces, cars, and the actual architecture, algorithmically, the sequence of mathematical steps to identify a car and a person overlap on a foundational level. So in the human visual system, light hits your eye, is projected back into your primary visual cortex and for additional processing in higher layers. In the lower layers, you have critical things like circle detection. So the same circle detectors that help identify people, there's someone's face there, actually ties in very elegantly to, those are the wheels of the car. So you have this multiplexing mathematically that allows the chips on our phones, that allow via cloud infrastructure for us to search through massive amounts of information.
Well, that's, it's a little bit more than I expected, but actually it's fantastic because it leads me into a realization, at least as I was listening to you talk, is when you unpeel how this all works, and a lot of this is you're going back into how human biology, which has evolved over so many generations, and also this notion of multiple components of looking at things and bringing it together. Your idea of circles and wheels and so forth sort of just brought that picture to life. That's really fascinating to see. You also talked about, and I think you referred to autonomous driving, and I guess I was going to react to that by saying, look, we talked about photographs on an iPhone for my mother of her grandkids. We talk about, at the other end, autonomous driving, both of them really involving computer vision in ways that we can all, each of us can feel and experience it. But just sort of moving away from that a little bit and coming into business applications, as you work with clients across the globe, give us some examples of, is computer vision ready? Is it at play? Are we using it in real life, actual enterprise applications?
Yeah, we're seeing some phenomenal applications across different industry areas. So for example, in e-commerce, it's possible to search via image. So for example, you're in a store, you're walking down the street, you see a piece of furniture in a real estate office, you can snap a photo and use that as the mechanism to search for that very same product. And so you have this fusion of something of interest and a way to go through the digital catalog. Another fantastic example in terms of repairing of machinery is if you have a worn bolt, you can actually scan that bolt and get a recommendation as this bolt is likely this product. And in terms of your question on whether it's prime time, it really comes down to confidence in the consumer that this recommendation is strong enough that I'll go ahead and order it now, as opposed to stopping to the store and sort of doing it the manual way. So absolutely, computer vision is being increasingly deployed in production.
Well, I tell you, I'd take any day, the idea of actually taking a photograph on my phone and then being able to identify the part number for that threaded or unthreaded screw, the screw that lost its thread, if you will, as opposed to having to drive down to the store and kind of walk through the aisles and try and find people with this little bit that I'm trying to show them and try and get a replacement part. So I can clearly see that. But it's fantastic to learn that it's actually in play already in the e-commerce world. As good and as amazing as that realization is and all the benefits we can see on the back of that, I mean, surely there are lots of challenges and there are lots of concerns around computer vision. Let's talk a little bit about that. I mean, what do you think about the world of deepfakes?
Yeah, as with any advanced technology, can be used for good or for nefarious purposes. So deepfakes is an area of research that's broadly around projecting one facial skeleton onto another. So you could think of all sorts of positive examples in terms of movies and animation. You can have even works of art become animated for interactive experiences in museums. Deepfakes in particular, however, is one of the more sinister uses, whereby you could project a false message, recreate the structure of a head of state to distribute disinformation or propaganda. So exact same technology, use cases can be across the board.
What you're really saying is I can create a version of this podcast, this video cast, and actually change what you're saying into something completely different and make it look like it's completely authentic and real. And that's very scary, particularly when you get out of this context and get into a political context with all of the implications that it has. Okay, so we explored some of the advances we're seeing in computer vision. We talked a little bit about some of the use cases that I think we're already starting to see in business life. And obviously, there's a concern, and I think as with any other piece of technology, as you rightly pointed out, we have to be thoughtful about how we apply it. But okay, so I'm going to get started. We're an enterprise. We're looking to embrace AI. We're looking to deploy computer vision. Where do I get started? What's number one, number two, number three on my list?
Some fantastic thought leadership coming out of academia is this idea that many business areas can be viewed as a prediction challenge. So the first step is to identify what part of the business can be disrupted for positive benefit of the end consumer. So let's take the new retail example of ordering a part via something that might be broken in your home. That realization has to be made, and that has to be set as a goal that we want to reduce the time it takes for a customer to purchase a product. And that being high fidelity, that being specific to the need at that moment.
Interesting.
Once that's set, is, well, can we predict with visual information what the customer needs? Subsequently, to actually execute against that, you're going to need partners. So for example, some of our work with Cora, there's some fantastic work in open source. There's going to be a need for the formulation of that specific visual search task. There is ways to accelerate this, and we view this for some of the fantastic leadership, Sanjay, in terms of transfer learning in particular. So if you're trying to find a bolt, you probably don't want to start with a neural network from scratch. You're going to want to start with something that already knows how to identify household items. So looking for neural networks that are close to that new business innovation. The last piece in terms of operationalization is this using state-of-the-art graphics processing units or increasingly different specialized hardware to make sure that this computation can be done in a cycle time that is short enough to matter for the consumer. And then monitoring all this, rolling it out, getting the message out there that this is possible, brings it to loop with all the, of course, change management, to have this new channel.
Interesting. So let me see if I got that right? I asked you, Armen, what are steps 1, 2, and 3 for me to get started? And I think you very cleverly actually said step number 1 is don't start with the answer, start with the problem. You worded it differently. You said go back and take a look at the problem, understand what it takes to solve it. But really what you're saying is, all of this enthusiasm aside, Sanjay, start with the problem, don't start with the answer. And I think that's great advice. So that's number 1. And I think, by the way, it's very true for what we see in the industry. I think the second thing you said was there's a number of capabilities, technologies, platforms that are already available that we can go out and start bringing into place. You don't have to sort of get started from the scratch here. And I think your advice to us is go out and take advantage of what exists and build on top of those platforms that are available in the ecosystem. And I think that's advice well taken. It's obviously something we do a lot of. And I think the third thing, if I understood you correctly, you're saying is, look, once you start with the horizontal platform and the great ones that are already available, you have to tune it, that you have to adapt it, that, back to the example of that screw versus starting with something else, you have to pre-train it with the right information. Then you have to think about operationalizing it because you likely will have exceptions, you will have some misses. You want to start using that as a way to learn, to apply transfer learning, to apply reinforcement learning, to keep it up and running. So number 1, start with the question, don't start with the answer. Number 2, build on a strong base of available technology already in the market. And third is actually think about pre-training those AI algorithms and think through how you can industrialize and run them at scale. And I think that's advice that's really well taken. Thank you for that. Armen, is there anything else that comes to mind before we close today's show on computer vision?
Yeah, it's a very exciting topic. And the one item I'll leave is that it's highly complementary with other AI technologies. A block of text typically can come in a report, but there's often subtle visual information, the logo headers, any figures embedded. So what we've been seeing is that using NLU in tandem with computer vision, in tandem with things like graph analysis, leads to unlocking of unprecedented values. It really comes down to having the creativity and vision in the marketplace to do business in new ways.
On that note, I want to thank you for your time today. And I want to thank our viewers for joining us. We'll look forward to sort of the next edition of this program. Thank you. Bye-bye.